In this video, we're going to talk about simple transformation of functions. This is where we raise functions, stretch them, switch them left and right, or reflect them. First, we need to cover some basics. Following the order of operations, we do multiplication and division first, then adding and subtracting. I'm going to use the terminology apply before the function and apply after the function. So for example, if I have the square root of x as my base function, then anything that is done inside the square root is applied before the function. Anything that's done outside the square root is after the function. To do this, we're going to need a graph. So let's draw a graph. And then we're going to start with a function. Let's start with a function called f of x, and that's going to be cherries. And so y equals f of x is cherries, and we're going to demonstrate that by having cherries on screen. I know it sounds weird to have a function called cherries, and just cherries will demonstrate better what we're doing because you can see things flipped around or stretched much better. If I add something after the function, then it'll raise or lower the function. So if I add 2 to cherries, then it'll raise the cherries up 2. Notice how the cherries have moved up because we added 2 to the outside of the function. If we had subtracted 3 instead, the cherries would have gone down 3 units. If I multiply the outside of the function by 2, then the cherries get to be twice as tall. And if I multiply f of x by 1/2, or divide f of x by 2, which is the same thing, then the cherries become half as tall. We can combine multiples of these things, and so if I multiply f of x by 1/2 and add 4, then first it squishes it down to half the size, and then it raises it 4 units. I can also multiply by negative. So if I multiply the function by -1 and I write it as negative f of x, then it flips it vertically. Now we've combined everything. First, we multiplied by 2 and a -1. So we multiplied by -2, which means we flipped it and stretched it vertically twice as tall. And then, following order of operations, we moved it down 3. Notice, since everything was applied to the outside of the function, everything happened vertically. Now let's see what happens when we do stuff before the function is applied, or inside the function, if you will. Everything happens horizontally and backwards. So when we add 3, we're actually moving it to the left 3. And when we subtract a number, we're going to move it to the right. And similarly, when we multiply by a number greater than 1, we're actually going to squish it. And when we multiply by a number less than 1, we're going to stretch it. And all of this happens horizontally. So here you see we subtracted 2 before the function is applied, and so it moves to the right 2 because it's moving horizontally and backwards to what we would think. And here, when we multiply by 2, we're going to squish it to half the width because everything applies in reverse. So multiplying by 2 makes it horizontally squished to half the size. Now let's combine these. We're going to multiply the inside before the function by 2 and subtract 4. Now, because it's inside, we're doing everything backwards, including order of operations. And so -4 is going to shift it to the right 4 and then multiplying it by 2 will squish it down to 1/2 the width. That also moves it closer to the origin because multiplying it by half the width also moves it over. So it was where the two stems meet at 4, and then we moved it when we squished it to half of 4, so we moved it to 2. So to repeat this, just make sure you understand. We first move it to the right 4, that's because of the -4, and then the 2x makes everything squish horizontally to half its value before. So the cherries themselves get skinnier, and as we do that, we need to squish in all the points to half the width. So what was at 4 now ends up at 2. Now we're going to combine a bunch of this. We're staying inside the function, so everything's going to be backwards, but everything's going to be horizontal. So notice we have a -1/2 x minus 2. So first, that's going to shift it to the right 2 because we're following order of operations backwards. And then it's going to double the width and flip it across the y-axis, flip it horizontally. So those cherry stems, where they meet, the -2 makes it show up at 2 on the x-axis. And then the -1/2 stretches it double the width, so now it's at 4 where those cherry stems meet, but then the negative flips it over the y-axis and puts it to -4. Now let's combine everything. We're going to do inside and outside. And we always start with the inside. And remember, the order of operations is backwards, and everything is backwards on the inside. So that we're going to start with the same inside we did before to make it a little less confusing. So the -2 shifts it to the right 2, and the -1/2 flips it across the y-axis and stretches it to be twice as wide. And then we flip it over the x-axis, because remember, now we're doing order of operations in the correct order, and then the -4 slips it down 4 units. So again, we shifted it to the right 2 because that -2. We stretched it to twice as wide because the 1/2. We flipped it over the y-axis because of the negative, and then the negative on the outside, flipped it over, and then finally we put it down 4 units because of the -4 on the outside. Thanks for watching, and you deserve a brain break, so go think about someplace nice and relaxing. I like to think about the beach, but rest your brain a little bit, watch the video again, and read your notes if you need to. Have a great day.